In this part, we will explain the ray diagram of diverging lens. And here in diverging lens, we said ray diagram. It's only one diagram because any position of the object, put the object anywhere, okay? All the positions you can put the object in them will give you the same characteristics of the image. They are only one set of characteristics: virtual, upright, diminished, in the same side as the object. This is different from the ray diagram of converging lenses, those we explained in the previous part, okay? Because in the previous part, the characteristics of the image was dependent on the position of the object. By changing the position of the object, it gives you new images of the new characteristics of image, okay, in converging, but not in diverging. Well, in diverging here, let's sketch the diagram, the ray diagram of the diverging lens. First of all, as we agreed together, we will put the principal axis, okay. This is the principal axis. In the midpoint, we will make a vertical line that represents the lens. Okay, it's diverging. So we will make it as following. Sometimes they make it like this. This is the symbol of diverging or concave lens. Okay, but we are not interested in this. Then let's put the points, the main points, those we will use. This is the optical center. At certain distance, we will put F, which represents the focal point. At equal distance, we will put 2F, and we will repeat this on the other side. This is F, this is 2F. By the way, we agreed together that this side is called the object side because we put the object to left, and this side is called the image side. Okay, so if the image is formed here, we will give its distance, the distance of the image Q, we will give it the positive sign because it's in the normal or the expected side. Let's write expected image side. But if the image is formed here in the object side, it will take negative sign in its distance. Okay, as I'll explain a few seconds later, inshallah. So concentrate. Well, here, put the object anywhere. Let's make the object. This is the object. This is the object. We will make the object large. Y because we know that the image will be diminished. Okay, then we will make the rays. The first ray is parallel to make the ray reach the line. Okay, this is the first ray. Okay, this is the first ray. The second ray, we will make it with the green. This is the second ray, violet. Well, the second ray is passing through the optical center, so it will go straight. It will not bend. But the first ray is parallel to what? Parallel to the principal axis. This is the principal axis. Okay, this is the principal axis. So it will diverge. Don't say it will diverge such that it goes through the focus. No, this is not diverging. It's converging. It will diverge. It means it will go away. So it will go away such that its extension go through the focus. يعني it seems to come out of the focus. Okay, like this. This will be the direction of the extension. So it will go in this direction. So it goes away such that it comes from the focus. This is the extension. Well, if I ask you, where is the image formed? We said the image is formed if the two rays meet each other, but here one ray is going here and the other ray is going away, so they will never meet each other. So what will meet each other? The extensions. So the extensions here will meet each other, so the image is formed here. So this is the image. It will be formed here. So this is the image. This is the object. Someone may say, Mr., but the image here is formed in the side of the object. Yes, so its a Q, the distance of the image will be negative. Why? Because it's not in its normal or expected side. It's not in the expected side. Okay, what are the characteristics of the image? The image is virtual, upright, it's diminished, smaller than the object, and at the side of the object. And because it's in the side of the object, the distance of it will be given the sign negative in the low. This is the diagram as it's sketched in Holt. This is the first ray. It goes away such that it passes through the focus. This is the second ray. Okay, it goes straight. When they meet each other, the image is formed here. Mr. You didn't sketch the third ray. Yes, I didn't sketch the third ray because two rays are enough. Well, this is the lens equation. It's the same as the mirrors equation. Okay, 1 over P plus 1 over Q equal 1 over F. P is the distance, the object distance from the lens. Okay, Q is the image distance, and F is the focal distance. And here also, F, which is the focal distance, is R divided by 2. Okay, F, which is the focal distance, is R divided by 2. What is R? R is the radius of the curvature of the face or the surface of the lens. Okay, because it has two surfaces, so it has two R's. Okay, well, the magnification of the lens is H dash divided by H. H dash is the image height, H is the object height, or negative Q divided by P, Q the distance from the image to the lens, P the distance from the object to the lens, as we explained in mirrors. No new points here. Well, now inshallah we will talk about the sign convention. The sign conventions here is so easy, okay? But first of all, let's sketch the principal axis. This is the principal axis. Here, this is the lens. We agreed together that this side is the object's side, because we put the object here. This side is the expected image side. Well, so here, if the object is here, it will be positive. خلاص ما عندناش مشكلة. And the object will be here. Sorry, it's not Q, I'm so sorry. Sorry. Again. This is the principal axis. This is the lens. Okay. So this is objects. Side. This is the expected image side. So if the object is here, the distance of the object will be positive. And the object in our study will be always here. So the object in our study will be always positive. Sometimes it may be negative, but it's not in our study. Okay? Well, if the image is formed here, so the image will be negative because it's not in its expected side. Okay? If the object is up, it will be positive. If the image is up, it will be positive. If the object of the image is down, it will be negative. If the image is formed here, the image will be positive because the image is in its expected side. And we said the converging lens is a positive focal length. And the diverging lens has negative focal length. So we said the converging lens is called, sometimes it's called positive lens. Okay, we can summarize this as in the following table. The object location, it's positive in our portion or in our study, and this is not in our study. Okay, the negative case. The image location, the image in back of the lens, back, it means in its real position, okay, it will be positive back in the expected, okay. The image in front of the lens, means what? Means with object, okay, with object, it will be negative, okay. The height, if the image is upright, it will be positive. If the image is inverted, it will be negative, okay. The radius of curvature and the center of curvature, okay, if it's back, it will be negative. If it's front, it will be positive. But this point is not accurate, not accurate. Yani, it needs details to be said. We don't have to say them, okay. The focal length, if it's converging lens, okay, the focus is positive. If it's diverging, the focus is negative, as I said a few minutes ago. Well, now we will have an example, a numerical example, to be able to apply. Let's read the example together. An object is placed 30 centimeters in front of the converging lens. Well, let's extract the givens. Here, 30 centimeters. This is the object's distance. And we said in our study, P is always positive in our study, okay? So it will be 30.0 centimeter positive. Well, in front of the converging lens. Converging lens means focal distance should be positive, okay? Well, positive what? We will know later, inshallah. And then 12.5 centimeters in front of a diverging lens. So we have another case where P, so this is number 1, and this is number 2. Here P equal 12.5 centimeters. It's all positive, okay? Both lenses have a focal length of 10 centimeters. So here F is positive 10 centimeters, and here F, because it's diverging, this is diverging, so F will be negative 10 centimeters. Well, we have F and P. Without asking you, you have to know that you will find Q from which formula? From this formula. 1 over F equal 1 over P plus 1 over Q, okay? Then 1 over Q equal 1 over F minus 1 over P. Then make your calculations as I'll show in the next slide. Well, so for both cases, find the image distance. Q is the image distance, okay? And the magnification, well, for magnification, we will use the formula M equal H dash divided by H, or we don't have H dash divided by H here. We don't have H dash nor H, so it's not used. So we will use negative Q divided by P, okay? Negative is in the formula. Q here will be substituted with its sign, and Q with its sign, positive or negative, and the P will be substituted with positive, as we said. To see the calculations of this problem, these are the givens here. Okay, this is the case of the conversion. If you observe that M is negative, and here the magnification, as we said, if the magnification is negative, it means the image is real and inverted. If the magnification is positive, it means the image is virtual, and it will be upright. Okay, here it's negative because it's inverted or upside down. Here it's positive because it's virtual or upright. Here it's smaller than 1, not because it's negative. Negative is the sign. I'm talking about the magnitude. So here it's diminished. The image is half the object. But here and here also it's diminished. Okay? Well, let me remind you that if the M is -2, for example, what does it mean? Negative means it's inverted, so it's real. But 2 means it's magnified 2 times, or magnified by a factor of 2. Alhamdulillah, we finished this section, and inshallah Rabbil Alameen, I'll send you the attendance quiz. You have to listen well and watch these 2 parts of the video well, and inshallah Rabbil Alameen, once you finished them and study them, solve the attendance quiz to take the marks of attendance of this session. If you didn't, join it online. Thank you very much, and Assalamu alaikum wa rahmatullahi wa barakatuh.